All right, in this video, we are going to implement logging out. I do actually kind of want to change something here. The get user for client, I only wanted to return the authentication if the is logged in is set. So I'm gonna say I'm actually gonna change this up a little bit. I'm gonna say if not auth, return null. Otherwise, return auth is logged in auth. Otherwise null. I could have combined that into a single statement, but I think for clarity that makes a little bit more sense. But I just want that. I just want to make it clear. I want get user for client to be a very easy way to determine if a user is logged in or not. So if it returns null, that means they have no authentication context, implying that they don't have a user, or they're not logged in. So let's go ahead and do logout client. Logout client is going to be underneath login client, but it's going to be a synchronous method. It's not going to return an observable. So do logout client, and I'm going to say const auth equals this get user for client. I'm say if not auth, return. There's nothing to do. Otherwise, const index equals this user list index of auth. And then I'm going to say this user list splice, use the awesome splice method to delete it. Then I'm going to delete it from the user map, this user's auth name. So delete this user's auth name. And then I'm going to delete the auth context. So delete client auth context. Then I'm going to say this IO emit users removed, and then pass in the full auth. And then I'm going to say console log user. Let me get the username first, actually. I'm going to alias that out before I delete the auth context. Actually, no, I don't have to. I have it available right there. I can say user auth name logged out. All right, let's go ahead and plug this into our client API. We're gonna call this in two different places. So on auth logout, we're simply gonna say this logout client. But I'm also underneath client on actions. I'm also gonna say client on disconnect, which is an event fired by socket.io. Not surprisingly, when a user disconnects. So client on disconnect, and I'm gonna say this dot logout client. I don't have to worry about anything as spectacularly happening if the user isn't logged in, because we already have that guard in place to make sure that they are logged in before we attempt to do anything with logging out. Okay, this is going to require us to implement the user's removed event on our store. So before we take a look at this code working, let's go ahead and implement that. And this comes back into the way that we're managing the state, which again is going to look a little weird to you guys. I know that, but this whole series is about expanding your mind. So what I'm going to do, in order to handle the user's removed event, I first have to add it to my events, my merged event stream. So this server on money, users removed, map op remove. And then what I'm going to do is down at the bottom, I'm going to implement the op remove, function op remove user, which is going to return, again, the ops return a function. Wait a sec. Whoops, I have a casing problem here. It's lowercase op remove. Sorry about that. And that was ESLint being a bro right there, squigglifying something I hadn't expected to be squigglified. And so again, this returns a function that changes the state. Again, that's what it does. It gets the state so it can manipulate it. And in a lot of context, sometimes what you would do is you'd make this immutable to where you return a new copy of the state. And that's a really interesting thing. And I want to point out here that doing that would be fairly trivial in this application. In this instance, however, I'm not doing immutable state. I am directly mutating the state. But you can trivially do that right here. So let's go ahead and mutate the state. So we'll say const index equals state users index of, or actually even better, underscore dot find index state users, and then pass in a object to match on, which will be name is equal to user dot name. And then if index equals or does not equal -1, then I'm going to say state users splice index 1. That's not how you spell index. And then I'm simply going to return type remove user state. Again, so our components can have an opportunity to respond to this particular state change. as well as get access to the entirety of the state. So yeah, an interesting thing, and I'll actually bring this up probably in the conclusion, to do here would for you guys to actually go in and try to make these state reducer thingies. I don't want to call them reducers because reducers are by nature supposed to be immutable. They function similarly though, and it would be a great exercise to try to express that here. But stuff and things. So yeah, now we have our op remove, and that actually will make everything work, hopefully. I think, maybe. So let's go ahead and open up our browser. I'll go ahead and hit F5. We see that woe is logged in. If we duplicate this, we'll see that we don't log in again. So both players, both tabs have woe logged in. But if I close the first woe, check that out. User woe logged out, and we now have 0 users. All right, the last thing that we need to do is keep track of who we're logged in as. I think that would be a good thing to do. So in our auth store, we are going to write a stream that we can use to keep track of whether or not we're logged in and what user we're logged in as. So I'm going to say, I'm just going to call this auth, just another section. Sometimes I like delineating these long methods with sections. Sometimes I like breaking them out into their own methods. But I'm simply going to say this current user money equals observable.merge, and I'm going to merge on this server. Whoops, I did forget something on the server side. I'll fix that in a moment. Auth login, and we'll do auth login, and then we'll do this server on auth log out map to an empty object. And then I'm going to say start with an empty object. And then I'm going to say publish replay of 1. And then I'm going to say ref count. And then I'm also going to say this current user dot subscribe. User goes into this current user. And then I'm also here at the top, I'm going to add 2 getters. Get current user returns this current user, and get is logged in returns this current user, and this current user is logged in. So now we have 2 synchronous ways of getting whether we're logged in and what user we're logged in as. And we have the asynchronous event stream via the current user money. So basically what I do is I say merge in a login and a logout event. Login event happens when we log in, and we get we get our user data back when we log in. So I don't have to map it to anything. But if we get the logout event, which I'll implement here momentarily, then we'll map it to an empty object. So an empty object represents a user that's not logged in. We start with an empty object so that we're not considered logged in. We publish replay 1, so whoever subscribes to this will get the latest user. And then we ref count it to make it be shared. And then finally, let's go down to the bottom and say logout money equals return this server emit action auth logout. Actually, you know what the funny thing is I don't need to explicitly invoke auth logout from the server, because when I log out, I emit an action auth logout, and when that completes on the server, it's already going to send me that acknowledgement that we logged out through our observable socket. So I don't even have to implement that, and that's really cool. And that's our login and logout. So now what I can do is, let's go ahead and test that. Over here on my application.js, I'm going to say services user store current user money subscribe user console log user. And for this, I'm going to remove the console log out of there. We're just going to say subscribe, blah, 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 doesn't matter. And then I'm going to say window.set timeout in 3 seconds. And I'll say services user store dot log out. This is like poor man's unit testing, isn't it? But don't worry, we'll be implementing the chat module next. So with that ready, let's go ahead and refresh over here. Let's watch our console, and let's also watch there be an error. Argument is not a function. Are you looking for map to? I broke something. Oh, yeah, I broke something. Understores users. You know, I just found out that there is a thing called map2. That's a handy error message. Let's see if it works. Map2, according to the source code that I'm reading over at reactivex/rxjs, will do a map, but it'll map to a specific value. Whereas a normal map expects a function like this. A map2 apparently will just return this value. It'll map whatever to that value. And I think that might be exactly what we're looking for here. So refresh, look at our console, and check that out. We're logged in, and then we're logged out. So notice that we subscribed to the current user, we got an empty object, and then we got our logged in object, and then we got another empty object. So we started off logged out, we then logged in, got all of our profile information, and then we logged out. And we got that just by subscribing to that one observable. And that's really, really powerful. So I'm actually going to do something interesting. Remember this auth section I have up here? What I'm going to do is I'm going to write a little bit of code that's going to add a class to my HTML node, depending on if we're logged in. So that way I can conditionally style the page based off if we're logged in, and use CSS instead of using JavaScript to show and hide specific controls. So I'm just going to say money HTML equals jQuery HTML, which ESLint is helpfully reminding me I have not imported yet. So let's jump up here to the top. I want to do this before importing shared operators. Import money from jQuery. This is kind of funny right here, this additional line spacing. I'm very particular about my empty lines and line spacing, and I kind of group things together. So at the top, we have the group of node modules that we're importing. Then we have our shared code. Then we have our CSS. And then we have our internal to the current application modules. And I kind of see each one of those as a different group, which is why I'm adding a new line in between each one of these. So just if you guys were wondering why it looks weird, that's why. It makes sense to me. I know sometimes weird things make sense to me. Anyway, so what I'm going to do now is I'm going to say services.userstore.currentUserMoney, and I'm going to say .subscribe. User goes into, and I'm simply going to say if user.isLoggedIn, and I'm going to say html.remove class. If we're logged in, remove class not logged in, and then HTML add class logged in. Then I'm going to copy and paste these two lines, add an else statement, paste them in here, and then invert whether we're adding or removing classes. So if we're logged in, we remove the class not logged in and add the class logged in. Otherwise, we do the opposite. Super exciting stuff. So let's go ahead and before we test that, let's go ahead and jump down here and remove this code right there, but keep our login call and keep our logout call. And let's see what happens. I'm going to expand my my Elements tab on my tools here, and I'm going to refresh. So HTML logged in, and then not logged in. Beautiful. And with that, let's actually go ahead and remove this code now. Now we no longer need to test this. In the next section, we're going to be doing the chat form, which is going to allow us to log in. So with that out of the way, if I refresh, we should start off with not logged in as the HTML class, and we do. So again, now we can use CSS to conditionally show and hide different things depending on if we're authenticated. So with that, I think that wraps up our users panel, our user store, and our users module. It's the simplest of the modules. Well, actually, the chat is actually also really simple, but the way I've written this, you can't chat unless you're logged in. So yeah, that's why we had to do the users first. So to recap this section, I suppose, again, we implemented the users.js, which is right here, which is responsible for getting a list of users and responsible for whether or not we're currently logged in. And then we have these pseudo reducers here to manage not only our state, but to also manage whether what operation led to that state change. Then we have our components user.js, which we just ties into our user state and add as users to a UL. Very straightforward. And then finally on the server, we have our users module, which is just responsible for the server side logic involved. But with that, I think we will see you guys in the next section when we work on our chat window. So that should be exciting. See you guys then.